Hello everybody, and welcome to another episode of Math with Sohn. Today, we are going to be learning how to factor the easiest way that I know. So let's get into it. If you have a factoring problem, that means that you have something that involves an x squared and an x, and typically a third number as well. And with factoring, if you need to factor, you can be given just this, or you could be given a different factoring problem that has an equal sign and hopefully equals 0, because you can't factor unless it's equal to 0. Now, given this information, this is the easiest possible setup because you only have an x squared. There's no number in front of the x squared. And if that's the case, if you have no number here, then you just need to think of two numbers that can multiply to equal 10, negative 10, and then add to equal 3. Okay? So what you can do, and some people do, they write off 10 off to the side, and they just list out the multiples of 10, things that multiply and can equal 10. Well, I know that's 1 times 10. Don't ever forget 1 and 10. And that is 2 and 5. Now, 10's relatively small number, so it only has these. Okay? And out of these, which numbers will multiply to equal 10 and add or subtract to equal 3? So if you add a negative number, it would equal potentially still like subtracting. And in this case, the numbers that would do that would be 2 and 5. So I'm going to put parentheses here. And the numbers that I know I'm going to have to use is going to be the 2 and the 5. So let's just place those there. Because this is only an x squared, I'm going to put an x here and an x there. And the only thing I have to fill in now is, what are the 2 and 5 going to be? Are they going to be positive or negative? Well, if I have to add to positive 3, that means that I'm going to have a positive 5 minus 2 to equal regular 3. And equivalently, this is factored. If you were just factoring, that would be your answer. If you solve, or you're asked to solve, if it equals something, if it has an equal sign, equals 0, then this will still equal 0. In order to solve, you would have to individually set both factors equal to 0. So that would mean that x minus 2 would have to equal 0, and x plus 5 would have to equal 0, which in this case means add 2, x equals regular 2, subtract 5, x would equal negative 5. And we would have our two answers with a quadratic expression with an x squared raised to the second power. You should expect to have two answers. Okay? Now this is the easiest scenario you could be given. A slightly more difficult scenario would require that you do a little bit more work, but not much more work. So let's try one of those. So a slightly more difficult scenario would mean that instead of having a plain x squared like we had here, it means that we're going to have something like a 2x squared or a 3x squared, something like that. And I'm going to do plus, let's go with 9x plus 9. And I'm still going to solve. I'm going to still say it equals 0. So now it's a little different. Because we have a 2 here, it's no longer going to be what multiplies to 9 and adds to 9. What you need to do is you need to actually take these two numbers right here, multiply them together. So you're going to do 2 times 9, that's equal to 18. That is what you have to actually multiply to equal. You are still going to have to add to 9. So we still need to add to this number. We need to multiply the 2 and 9 together, but we still need to add to that middle number. So I wrote out the 18. That's what the 2 times 9 equals. Now what will multiply to equal 18 but add to 9? That's what we're looking for. So I'm going to write out the multiples of 18. 1 times 18. 2 times 9. 3 times 6. Out of these, which one will add to 9? Well, that would be the 3 and the 6. Those two numbers definitely add to 9. 2 and 9, that adds to 11. If you subtract them, you get 7. 1 and 18, not going to happen. It's the 3 and the 6 that we'll be using this time. So I'm going to put my parentheses here. I'm going to put my x's there the same way. I'm going to still put my 3. I'm still going to put my 6 there. And in order for this to add, 3 and 6 to add to 9, in this case, they are both going to be positive. Now, this is not done. Like the last problem, this was finished. Now it's not done because there is a 2 here, and we multiplied the 2 in the beginning. You have to balance that out by dividing both of these numbers by 2 right now. So we put the 3 divided by 2 and the 6 divided by 2. If it divides, great. 6 does divide by 2. You get 6 divided by 2, that's 3. That's simple. If it does not divide by 2, like 3 does not divide by 2 or simplify, it could simplify, then what you do is you take that 2 and you're going to put it in front of the x. So that means that we have a 2 in front of the x plus 3. It didn't divide the 3. And then the second factor, the 6 did divide by 2, the x plus 3. If this was just factoring, we'd be done. These are the factors. If we are solving, in this case we are, and it equals 0, then you would have to individually set your factors equal to 0. 2x plus 3 equals 0, and x plus 3 equal to 0. This one will require a little bit more solving. We will have to subtract 3. 2x equals negative 3. And then divide by 2. X would equal negative 3 divided by 2. And then this one, all you got to do is subtract 3. Now you may have noticed something about your answers in these, and that is that they are always going to be the opposites of the factors. Like here we had a 3 over 2 and it turned to negative 3 over 2 for our solution. Here we had 6 divided by 2, which is 3, and it turned into negative 3 as our solution. And that is not something that is coincidental. That will always happen every single time. All right? That's going to do it for this episode, everybody. Until next time, stay thirsty for knowledge, and I will see you later. Bye.